but all the kind of, when you do this thing for real, you're in a different room in a different city, and you've done different things that day, and there's all these different elements that you can incorporate into what you're doing. With online meetups, it's a little more difficult. I mean, I am standing in a different place in my home office today, so that's very exciting for all of you. But I suspect it doesn't really come across as a flurry of unbridled excitement on the other end of the call.
Well, we can't see, man. We can't see. You've got it's almost I'm watching like a dubstep YouTube video.
This is where I live.
Okay, well, yeah, that's where you live in.
Yes, this is actually my house. I've had a little work done on the place. This is where I race my light cycles after hours to relax after a hard day of zooming. So
yeah, they used your house for the set for Tron.
Actually, I bought that set off them after they finished making the movie. So, well, behind the virtual background, there's a green screen, and behind the green screen, there's a wall full of guitars. And if I show that, people generally pay as much attention to the guitars as they do to anything else that's happening. So,
fair enough.
We're going to talk about the guitars at the end if folks are into that kind of thing, you know. But no, I've had sessions where I was like, "Are there any questions?" And someone's like, "Is that a Telecaster?" It's like, all right, that's the thing you took away from my talk today. So
yeah, anyone who hasn't got questions about the guitars, put your hands down, and they all put their hands down slowly.
Right. First, we'll do questions about encoding systems, and after that, we'll do questions about Fender guitars and how many is too many, and why I need one more, and what it's going to be, and what's the one I'm going to buy after that, and we'll take it from there. So. Nice. Hello, folks. Welcome, those of you who are just joining. Nice to see you all. Do feel free, by the way, if you're somewhere you can switch your camera on and you want to do that, switch your camera on. Makes it friendlier. I've been doing this long enough now since the lockdown started last year that I can absolutely do this talk to the webcam and the little Lego minifigs who are my regular studio audience. But if I can see a couple of your faces, it always makes things a little friendlier. So.
Nice. Nice. We'll give it a minute or two. I think we've got about a quarter of signups are on now. Cool. Always tends to be the way that about half, I think, about half of which turn up. We had 100 signups, which is how you know it's going to be a good session, man. So
yeah.
So yeah, we'll give it a few more minutes. But seeing as it is recorded, like I mean, when we first started, we'd give it 5-10 minutes for the room to fill up. But I mean, yeah, might as well just kick to it once we give it a few minutes.
Given that the room is the size of a Zoom call, which is what, 300 people on the standard license, waiting for it to fill up might take a while. So.
To David's question, no, if you put your webcam on, you don't appear on the screen view. Only Dylan and the screen he's sharing comes up on the screen view. So don't be shy.
It's all about me, darlings. There's no space for any of you. Me, my slides, and my ego are more than enough to fill a 4K high definition recording. So no, I started getting invitations to in-person events again, and I'm like, really?
You know? Yeah. Well, for when? For June or?
The earliest one I've got is the beginning of June. Small, like just spread across multiple venues.
Yeah.
So there aren't too many people in any one place, and then September, October, and then the big events in November are all like, yeah, we are going ahead. We are going ahead, or we are going bankrupt, and we do not plan on going bankrupt, so we are going ahead.
Well, I think after last year, you know, I think a lot of people, you know, all those events have now been rescheduled, you know, and they're like, you know, we're not gonna, you know, we're just gonna throw caution to the wind and make sure everything goes ahead and close our eyes and cross our fingers just in case.
No, I was on a call the other week with a whole, like about 55 people, all of whom organize meetups and conferences and events all over the world. And, you know, one of the big questions is, as event organizers, what are you allowed to insist on in terms of, you know, vaccinations or COVID testing or any of that kind of stuff?
Yeah.
And there's some places that, like, you are not allowed to do anything. You are legally required to just let people walk into your event without doing any health checks whatsoever. And it's still your liability if they give everyone else coronavirus. And you're like, well, that's not very helpful. So, but we will, I guess, sort of slowly, there will be, I'm sure, at least one big technical event that ends up making a lot of people ill, and everyone's like, oh, I told you we shouldn't have had any events, but it'll be one, you know, there'll be dozens of these things, and it will, I can't believe it'll be perfect for everybody, but I think the vast majority of them will be. you know, they'll wait until the time is right and people understand and they're comfortable with the degree of risk, and then they make their own decisions on that basis. So.
Yeah. Well, about 30 minutes prior to this this session, I just had like a meeting in because I'm in the office. I try to make these in the office every Thursday, just because the advanced internet flow is much better. But we just had like a very quick meeting. We're going to be doing like lateral flow tests once a week. So on a Sunday night, we're encouraged to take a test, within 30 minutes if you're positive or if you're not. And then, for that week, am I allowed to go into the office or not, which is good because, I mean, I think it's every techie's dream for a fully remote setup, but realistically, I think everyone kind of is craving a bit of human interaction at the moment. So if you can go
all the human interaction that I miss going to the office is nowhere on the list.
No,
I miss pubs, I miss people, I miss travel, I miss flying, I miss events, I miss meetups. I will not be going back to any office anytime soon unless someone offers me a ridiculous amount of money to do so. So Matt says need hugs. Yes, we all need hugs, Matt.
No, mate, that's what I'm sick of. I'm sick of these. Can you see me when you put your elbow out and it's a very awkward, instead of a handshake, a little elbow, and I've had enough of them. I'd rather we did nothing at all, to be honest.
It is weird. It kind of makes you re-examine all the social protocols about, okay, so when we first meet, we rub our hands together and we do that, and that's just a thing that everyone does without thinking about it.
Yeah. Well, we'll start the session in a minute. Firstly, whereabouts I think I probably asked you when we spoke last on the phone, but whereabouts in London are you based?
Forest Hill in southeast London.
I probably told you that's very close to me. I'm in New Cross, so you're
just up the road. I will be heading up there before too very long because that's where a lot of the good pubs are. The New Cross Inn.
New Cross Inn.
Choice.
Yeah,
I have tickets to about 3 events that all got postponed from September to December to February to May. So
you walk past here at like 11 o'clock and all you see is a very sweaty window as you go past, and loads of people jumping up and down and running into each other. And, I know that very well. So maybe sometime not too soon, maybe we can have a beer, I'm sure, once we're organising the next event we do together.
Absolutely.
But we've had a few messages in the chat already. For those who are joining us now, and for people who've been here since the beginning, as I was saying at the start, usually we do our Q&A towards the end, but it was really cool in our last event where we had a lot of people just putting stuff in the comment box kind of as and when it pops into their head. So if you do have stuff on your mind you want to get off your chests, Dylan, myself, we're going to be happy to answer these questions. So if you've got something to say, just say it.
Cool. Kick it off. So I see Mohammed is on from Jordan. Hey, welcome, Jordan. Drop your countries in the chat. Let's see how wide we're broadcasting here this evening. That's always fun to see where people are tuning in from and what time of day it is, and if anyone out there has stayed up till 5 o'clock in the morning to watch this.
Nice, cool. We've got a few from the UK, Sweden, Portugal, Spain,
UK,
Netherlands.
That's cool.
Yeah. Sweet. In Netherlands, Germany, Northeast Germany at the moment. Nice.
Traveling, going to another country. I know where Estonia is. Estonia is on my list of, Estonia is where Skype comes from. Skype was an Estonian startup. And one of the things I was going to do last year, and then I was going to do this year, and I'm probably going to do next year, is I want to do the cruise ship ferry kind of tour, the Baltics, Tallinn, Helsinki. I've done the Riga to Stockholm on the Baltic line a couple of times, which is a wonderful sailing. And the last big event I did before the lockdown happened last year was a conference on a cruise ship from Copenhagen to Oslo and back. But the sailing from Tallinn to Helsinki is one that looks like a lot of fun, and I've never been to Estonia yet, so I can't wait to visit. It looks like an amazing place. All right,
cool. Let's kick start. So 40 people on the chat already. Thanks everyone who's turned up. So this is number 11. I mean, we've been going since August. So as everyone knows, we're kind of picking up pace, and the events are really kind of they're getting good now. Well, they've always been good, but as kind of we grow as a group, we're going to be kind of changing the scope of these events. Of course, we're going to be continuing what we've been doing up until now and inviting people like Dylan to speak, but also we're going to be inviting companies, and unfortunately I can't say any names at the moment, but we've got a few kind of big enterprise level companies which are going to be telling us about their stories, kind of how they've been using .NET and kind of surrounding technologies to kind of get from 10 years ago to now. So yeah, keep your eyes peeled over the next few weeks and months, and yeah, there's some exciting stuff in the pipeline.
So Luke, the big question I have for you is, are you going to have to change the group from .NET to the core to .NET to the 5?
Yeah, that was it, because I posted the event in was it end of August? Obviously,
yeah.
.NET Core 3.1 or something was still the most recent version. So when it got to November, I was like, fuck, okay, maybe I need to rebrand. But yeah, we'll have to see, because I mean we're growing really quickly. I think as of today we're like 830 members.
That's excellent.
We were 400 just before Christmas. So before we get too big, we're a household. We don't want to be a household name.
If you get to 1,000 people, you're stuck with it then forever.
Yeah. So if anyone has any names, please put them in the comment box, and I'll consider them. But yeah, but of course we have a few people UK based here. Regardless of where you're based, I think Dylan Beattie is a name which is also familiar if you've been in the world of software development. Of course, the Art of Code talk online is probably one of the most viewed software development videos you can find, with several million views now. Dylan is a name which I've known for a long time from his days working at Spotlight. And of course, his efforts as a Microsoft MVP and just kind of all round kind of very ever-present name in the software development community, not just .NET, but through his efforts in all talks, in all walks of life in software. So
it's very stuff with computers and then standing up and talking about it.
Exactly. That's what we get paid for. But yeah, it's very hard to introduce Dylan. All you have to do is go onto his website, and there's about 4 different iterations depending on how much time you have to know about him. But I'm sure he can tell you more about himself and also the talk. There's no such thing as plain text, which if anyone read the introduction or were here at the beginning of this session, we're the first people, I think, to hear this. So he already has the hosting ability, so I'm going to put myself on mute and probably turn off my video. No, I'll keep myself on video, and I hope everyone can have theirs on as well. But yeah, put your questions throughout the session in the comment box, and I'll let Dylan take from here. So cheers, guys.
All right, thank you, and welcome everybody. And it's nice to be here. And I say it's nice. I'm here. I'm at home, and you're where you are. But it's nice to see you, and it's nice to virtually get together and do these kinds of events. Just a little. This is me, Dylan Beattie. I run a online training company that I started last year. I didn't start it as an online training company. I started my own consultancy to do lots of travel and go to lots of places and teach people about software, and that worked really well. So now I do everything online. So that's kind of my sort of day job, if you like. I'm an MVP with the Microsoft Developer Tools program. I run the London.NET user group, which are doing a series of occasional unconferences at the moment while things are sort of weird and locked down and all that kind of stuff. And I also, I once invented a programming language as a joke. This whole idea about, oh, we need a rockstar programmer, and someone on Twitter went, why don't we just make a language called Rockstar so that we can confuse recruiters? And boom, Rockstar started life as a joke, and then it was a joke specification, and then people liked it, and people implemented the joke specification, and now I'm the project manager of a joke, and it has semantic versioning and a formal test suite, which is hilarious. You can check that out at codewithrockstar.com, type in some code, push a button. If it runs, you're a rockstar programmer. Congratulations. But today I'm going to talk to you about plain text. And when I talk to people about this talk, I've done this at a couple of conferences, but this is one of the first, I think the first UK meetup group that I've done it with. But I say to people, it's plain text, and they say, plain text? You're going to talk about plain text for like an hour? And yeah, you know, because plain text, asking programmers, hey, what do you think about plain text? Is kind of like asking fish, hey, what do you think about water? You know, they're like, what's water? We live in this stuff. We swim around in plain text files all the time, all day, every day. And when somebody says to you, hey, just send me a plain text file, or can we download it as plain text? That's a kind of shorthand, because what they're actually saying is, I don't want to have to do special software and conversion. Send me something I can open and I can read and I can see what it's supposed to say. And to be able to do that, you know, plain text kind of works as a shorthand between people who speak the same language with the same alphabet in the same culture, using the same kind of computer with the same networking and the same all kinds of things. And for a long time, that was kind of good enough. But over the last sort of 20, 30 years, it has changed dramatically. And that's what we're going to be talking about today. Because, you know, if we go right back to the beginning of the whole thing, most technology is about, we want to get something from reality. Stuff that's stuck in the computer isn't much use to anybody. We got to get something interesting in there first. We have an idea or a piece of information, something happens in the real world. We need to get that into the computer, into the technology, and then we do something with it. We process, we analyze, we search, we send it flying around the world, but then we need to be able to get it back out at the other end. And if the person on the other end can see the results of that, if they can understand what it is that we were trying to convey to them, then we're onto something. You know, text and writing has been around for probably about 5,000 years, but it didn't get really interesting until about 150 years ago, when we had the bright idea, hey, what if we combine writing with electricity and invent the telegraph system? Now, the first telegraph systems ever used, this is a photograph of a thing called a Cook and Wheatstone system. It's used in England in the 1830s. It's, I think, the first instance anywhere of people using electricity to transmit text. Now, the Cook and Wheatstone system, like I said, 1830, so it's coming up on 200 years old, but there's a whole bunch of ideas in here that will sound familiar to anybody who has ever worked in technology. The two people behind it, Cook was a business person, Wheatstone was an engineer, and Cook wanted to sell it and Wheatstone wanted to give it away for free. Does that sound familiar to anyone who's ever worked in open source? And you know, Cook was of the opinion that you had to be able to sell this to people with no training. And Wheatstone was like, no, come on, this is a communications revolution. The least we can do is expect them to read the manual and figure it out a little bit. And Cook won both arguments. He won the argument about this was a commercial system they were going to sell, and he won the argument about we need to build a telegraph that makes sense to people who have had no training and haven't read the manual. Now, the system, it used 5 wires. The earliest one ran from West Drayton to Paddington railway station, distance of about 14 miles out in West London, out in what was beyond West London back in the day. And those 5 wires, so it took 5 wires, 14 miles long, each wire running along a railway line. And the way that you sent a single letter is that you connected a current across one pair of those wires. So you got one wire positive and the other wire negative. One, the current flew out, the other one, the current flew back. And what this meant is at the other end, one of these needles across the middle of this dial here would move. And one of them would move positive, one would move negative, and you would look at that and you'd read the letter where the needles crossed. And that was how you read off messages being sent on the Cook and Wheatstone system. Now, what this means in terms of information theory, this was the first encoding system ever invented. It only had 24 characters. It couldn't even do the full alphabet. And if you think, you know, Ascii and Unicode and all these 8-bit and 16-bit encoding systems of ones and zeros are complicated, be grateful. The earliest system we had was a 5-symbol trinary encoding system. 5 symbols, and each of them could be positive, negative, or 0. And all of these 24 letters of the alphabet were encoded based on a positive and a negative, which corresponded to the way these physical needles would move on that circuit. Now, the thing about that, the Cook and Wheatstone system there is those 5 wires, eventually one of them burned out. And they're like, do we replace the wire or do we figure out how to send signals using the 4 cables that we have left? And then another one burned out. And then they had 3 wires left and another one burned out. And they rapidly realized that a 5-cable telegraph system was going to be a maintenance nightmare. You know, there's this old thing, 4-engined airplanes have 4 times as many engine problems as single-engined airplanes. Well, it's true. You know, 5 wires meant they had 5 times more likelihood of a cable failure than if they only had a single wire. Now, while all this is going on, across the Atlantic, a guy called Samuel Morse is trying to figure out a way of building a telegraph system that only uses a single wire. Now, many of you will recognize this. This is actually not the Morse code that was invented by Samuel Morse. Samuel Morse invented an early version of this. The version that we use today, the version that you've learned if you sail or you're in the Scouts or you've done any survival training, is actually, it's a variant called International Morse code, which was standardized at a conference. They had a telecommunications conference in Paris in 1865. And all the kind of connected countries of mainland Europe went, yep, that looks good to us. We will agree that this is a standard. Now, if you ever worked in tech, you've ever built software, shipped things to customers, you'll know that when you have no users, you can change anything you like anytime you like, right? It's easy. No users, change it. Rebuild, reinvent, redeploy, do what the hell you like. Once real people are using your system to do real work, if you try and change anything, they are going to get upset. And the more users you've got, the harder it is to make breaking changes that are going to affect the users of your system. Morse code arrived in this international Morse code. It arrived at just the right time that as we connected Europe and the UK began running cables across into Africa and Asia, basically wired up the entire planet. This was the standard that everyone was using. And that meant there was too much investment in it. They were never going to be able to roll out an alternative to replace Morse code. And it lasted almost exactly a century. It was ratified in 1865. 1965, finally, critical mass in a new kind of information technology reached a point where, like I said, it's critical mass. There's enough impetus behind it, enough advantages that the breaking change became worthwhile because computers had been invented. And it turns out that Morse code is brilliant for all kinds of things. You've got one piece of wire, you can send Morse code down it. If you've got a signal lamp, if you've got any way of sending audio, you can write it down. But as a computer encoding format, it's not terribly good because it isn't actually dots and dashes. It's dots, dashes, and spaces, pauses. And the different lengths of the pauses mean that Morse code is not actually a binary encoding system. You need the gaps in it. We needed a better way of translating text into something that computers could understand. The American Standards Association, what would become the Ascii, which is what they're called today, but ASA is what they were called then. They sat down and they went, let's come up with a new system for it. The American Standard Code for Information Interchange, Ascii. Now, Ascii was and is phenomenally successful. When we talk about plain text files today, we are normally talking about Ascii and Ascii text and stuff. But like I said, asking programmers about Ascii is like asking fish about water. Most of us have never stopped to think about it. Now, 2 things you need to remember about Ascii. First of all, it was designed to work with mechanical teleprinters, machines that look like this. Most computers did not have a screen. They had a typewriter connected to an information processing system. And second, most computers didn't have magnetic storage. They had punched cards. So these were the requirements which informed the design of Ascii. And it's probably decades now since anybody used a teletype or a punch card, except for, hobbies and recreation and stuff. But Ascii was so successful that making any changes to it was practically impossible. Let's do a little guided tour of the Ascii character set here. Now, this is the first block of characters. Ascii is a 7-bit encoding, gives us 128 characters to play with, including null, 0, the full blank of zeros. Anyone who's worked with C or C++, you'll know we still use nulls today. If you see 8 zeros in a row, that's the end of the string. Stop reading the string, because if you keep going, you've got a buffer overflow error, and you're going to cause all sorts of mischief and havoc. And then we have a whole block of control characters. Now, these characters here, these were intended. Let me just adjust this layout a little bit here. So all of these were intended to send control instructions to those mechanical teleprinters and control the way the machines work. So start a heading, start of text, end of transmission. These were all about controlling how physical information, how electrical information flowed through physical cables. Most of them we don't use anymore, but if you wanted to enter one of these control codes into your terminal, you couldn't type null. If you wanted to type start of heading, ASCII 1, you pressed Control A, control codes. That's where the key gets its name from. Start of text was Control B, end of text, Control C. And that one has survived. That one stuck around. So when your .NET Core program goes into an infinite loop and you want to break out of it and you hit Control C, you are sending a signal that means end of text. It means stop what you're doing. Don't send me any more. Interrupt. I don't want to do that anymore. End of transmission, inquiry, acknowledge. We don't use those anymore. If any of you out there is sat at a Windows machine right now and you open a terminal and you type echo space and then you press Control G and you press enter, it will go ding and it will ring whatever your Windows default notification sound is, because that's the bell character. It used to physically ring a bell, then it became an electronic beep, and nowadays it sends a message to the Windows subsystem which will make it echo whatever your default notification noise is. Backspace, you know about. If the backspace key on your keyboard breaks, you can do backspaces by pressing Control H. That has been useful to me exactly once, but it was very, very useful on that particular occasion. Then we have the tabs and the line feeds and the carriage returns. Now, when you're looking at line feed and carriage return characters, you know, we have this sort of weird convention in modern computer systems. Oh, look, there's bubbles on there. Isn't that useful? There we go. We have this weird kind of this conflict, don't we, between the people who use so Surly's just said in the chat that echo Control G at the end of a batch file. Yeah, because that'll make a noise when it's finished. If you're copying like a couple of gigs of files and it's going to take a few minutes, you can put an echo Control G at the end of the script. And when it gets to the end, it'll go beep, and then you know that it's done. I've done that on MS-DOS, believe it or not, back when beep was literally a beep. Now, we have this whole thing about line feeds and carriage returns, right? And if you're an old Mac OS person, then you think a /R is an end of line. And if you're a modern Linux person, you think /N. And if you're Windows, it's like, no, /R/N is end of line. And we still, you know, I had problems with a file encoding problem on this a couple of days ago. This still happens regularly. So how did we end up here? Well, this is a mechanical teleprinter, and you send characters to it and it prints them. Plain text is really cool. And then when you get to the end of the line, you need to return the carriage to the start of the line by sending a carriage return. And then you want to click up to the next line on your page by sending a line feed character. Now, you could, if you wanted to print bold on one of your old-fashioned daisy wheel typewriter style teleprinters, what you could do is you could send a line, you could send a carriage return, and then you could print the same line again, and it would overprint it, and it wouldn't align perfectly, so you'd get bold, you'd get this overtype kind of effect. And then you can go back to the beginning and page up again. So carriage return and line feed, the carriage return on its own was actually useful. Line feed on its own, not so much. You might go halfway across and then go down and along and down and along, but that wasn't something that got used very often. That was pretty obscure. Now, when they started putting together the first Unix systems, Unix actually evolved out of Multics, and Multics was one of the earliest operating systems that supported the idea of a device driver. This idea that instead of the data talking to the hardware directly, the data would go through a translation layer. So you could use Multics with different kinds of terminals and different kinds of teleprinters. And because of this, they had a layer in their code to make this abstraction. And so they said, you know what, if we see a /N, that just means go to the start of the next line. That's a new line character, new line at the beginning, because why the hell would you start a new line halfway through? And that was baked into Multics, and then Multics evolved into Unix, and then Linux evolved out of, you know, as a project to clone the Unix kernel and open source. That influenced the design of Next Step, the next operating system. NextOS was acquired. That's what went into macOS, and that's why today Linux and macOS and Android and all these systems that have Linux and Multics in their ancestry, all of them have /N as a new line character. But Windows does it differently. because Windows 10 had to be backwards compatible with Windows 8 because all the people who were using it, which had to be compatible with Windows 7, which was Windows XP, which was Windows, we'll skip Vista for this, and XP had to be compatible with, yeah, that's exactly why. You see the M is a line feed coming in from Windows that on Linux systems just looks like noise. Screen's gone blank. Yeah, it's all right. Look, there's a penguin there. See? Hey, look, there he is. So yeah, Linux systems evolved from Multics, which had /n, but Windows had to be backwards compatible all the way back to Windows 95, which was MS-DOS, which was originally CP/M, and CP/M had to run on mini computers, and mini computers were cheap. And the cheap mini computer hardware didn't support device drivers. It didn't have that layer of complexity to keep the costs down. And so on those, to move the teleprinter to the start of the next line, you had to send a carriage return and then a line feed separately. And so we're stuck with this 30, 40, 50, however many years later. In .NET, chill. You just use environment.newline, which mostly works most of the time. I had a fun thing the other day. The problem with environment.newline is that if you are using it to write data or define things, it can be sensitive to situations where the system where you are building your code may not necessarily be the same as the system where you are running it. If you have a .NET program that's cross-compiled and you got a .NET version, you got a Windows version, and the .NET version writes that environment.newline as a form feed, as a delimiter characters, then when you read it in on Windows, it's going to be like, this has got Linux line endings. I'm not sure what's going on here. But anyway, we kind of figured out how to deal with this, right? Let's have a look at the next chunk of Ascii. There are some optimizations in here that most people kind of never realized. Now, the thing about Ascii, that had 127 characters of space to play with, plus null. There were more characters than that in the world. Certainly, there were more characters than that in use in print in North America, the English-speaking part of North America, but not very many more. They could almost cover all the characters they needed. There's a couple of obscure typesetting characters, like technically in typesetting, there's a minus, there's a dash, there's a hyphen, there's an n dash, there's an m dash. There's 5 different kinds of dashes. They went, no, we'll just have one. Hyphen can stand in for all those jobs. So they had to make some executive decisions about what punctuation to support. But I think they actually did a pretty good job. Now, when it came to the decimal numbers, one of the things computers have to do a lot is they have to turn strings into numbers and back again, because human beings read and write in terms of strings, but computers count in terms of numbers. If you want to turn an ASCII digit into its corresponding numeric value, you just ignore the left-hand half of it. You just chop off the highest 4 bits, and the bottom 4 bits, that is the binary representation of that number. This is why 0 starts at 48, because if you take off the 0011, boom, you've got 0. 1, 2, 3, 4, 5. So converting numbers to strings and back again was really, really fast in ASCII, even on the incredibly primitive computers that it was designed to run on. There you go. Just let me tweak this. I have a slide. The slide that's coming up next is on the screen here in a way that I can't quite see what's on it. This is a new setup, and the extra screen for it has yet to arrive because August said it would be in this afternoon, and guess what? It wasn't. So we are improvising slightly. Let's have a look at the alphanumeric characters. So you ever looked at an ASCII table, you've probably thought, well, why is capital A 65 and lowercase a is 97? Like, why did they pick those numbers? You know, what made any sense there? Now, the reason why they did this is if you want to do a case-insensitive string comparison, you can just ignore 1 bit. There is a single bit there that if you ignore that, big A and little a are the same. They are 32 bits apart, and that 32 is a single flag in the bit representation. So you could do case-insensitive string comparisons really quite quickly. And then we get to the end of the block. We finish up, you know, Z is 122. There's a couple of extra parentheses and quotation marks and, you know, punctuation marks. And then finally, there is del, 127. Now, the reason why del is this 1111111 is if you're writing data onto a punch card, you can't fill the holes back in. The only way to delete something in a punch card is to punch out all the rest of the holes so that whatever was on there before can't be read anymore. So the ASCII del character was the character that said punch out every single hole in this row. And there are anecdotal reports that if you deleted every single row on a punch card, you'd get something called a lace card. And with that many holes in it, it wasn't rigid anymore, and it would get crumpled up, and it would jam up the hoppers, and they'd have to take the mainframe off and open the thing up and take the little shredded bits of card out of it. So deleting an entire punch card was a nasty thing to do to your colleagues. But that's why ASCII 127, the delete character, is this solid bank of zeros. Now, ASCII finishes what they're doing, slap themselves on the back. They're like, we did it, chaps. Well done. And probably in an American accent, we did it, chaps. Well done. We've encoded all the world's information. And the rest of the world goes, no, you haven't. Don't be ridiculous. 127, we can't live in anything this small. Now, my personal experience of ASCII not being good enough didn't happen until I was about 10 years old, because I grew up in Zimbabwe. And so my earliest experiments with computing, Zimbabwe uses dollars and cents, and I grew up speaking English. So $, no problem. English alphabet, no accent characters or anything. I moved to the UK when I was 10 years old. I was doing some homework on my dad's word processor, and I wanted to type a pound sign. And I did, but then when I printed it, the wrong thing came out because the printer wasn't speaking the same version. Now, this character here, pound sterling, this is not in ASCII. Not there. The Americans didn't have space for it in 1965. And why did they care? They didn't use pounds in America. They used dollars and cents. So this character was missing. Now, you know, for a lot of cultures, Chinese and Arabic, ASCII was pretty much a dead end. Like, you can't even start from here. But for quite a lot of cultures, ASCII was almost good enough. You know, in the UK, ASCII plus this sign did everything that we would have needed it to do. Lots of Western European alphabets just needed ASCII plus a couple of extra characters. And so what a lot of people did is they looked at ASCII and they went, we've got 127. There's an 8th bit here. Hey, is anybody using this bit? And nobody said, we are. And so everyone jumped in. They went, right, brilliant. We're going to use the top half of ASCII to do our thing, to do the extensions to it that we need. And everyone had this idea at around about the same time, and they all started, you know, jumping on it, and different companies and different countries came up with their own rules for what the top half of the 8-bit ASCII character set looked like. One example of this, each one of these different standards became known as a code page. So if you ever worked with code pages, a code page is a rule for saying this is what the top block of ASCII means right here, right now in this context. This will be familiar to developers and technology enthusiasts of a certain age. This was code page 437, which shipped with the IBM PC and became really influential in terms of, you know, building console applications for DOS and certain kinds of Windows machines. Now, they used the second half to do all of these box drawing characters. It includes most of the Western European alphabet accent characters that you need. It also includes half of the Greek alphabet, because they didn't have enough space to actually write Greek, but they did have enough space for all of the Greek characters which are used in physics and mathematics. So that's why about half of the Greek alphabet is in the IBM PC code page, because they wanted to be able to write physics formulae and those kinds of things. The other thing that they did with the IBM PC is they went, hey, we don't actually need carriage, return, line feed, all that kind of stuff. We can come up with different meanings for the first 32 characters. And they did. And if you've ever seen an IBM PC crash so hard that you end up with a screen full of playing cards and smiley faces, what has happened is it's basically spitting out control codes that it is trying to render as text onto the screen. It's got its encodings in a twist and it's fallen over sideways, and you need to switch the power off now. So that was 437, one of the most popular code pages. You go on Wikipedia right now and look up code page. Here is the list of the code pages. There are hundreds of these things. Windows, so Microsoft came up with a whole bunch for MS-DOS, and then they came up with some more that only work on Windows. IBM came up with their own set of code pages. Different governments around the world established code pages for their domestic IT industries. Apple has a whole set of code pages that weren't compatible with any of the others. Everybody had a different idea. And, you know, even if you could agree on a code page, if you wanted to say put Russian and Hebrew in the same document, you couldn't, because there was no code page that supported both of those encodings within the same piece of text. Now, this was kind of okay up to a point. WTF8. I love that, Kai. I'm going to keep that and I'm going to use that. This was kind of okay up to a point. For most of the 1970s and 1980s, we used computers to do work that ended up getting printed out. And as long as you could get your computer and your printer speaking the same code page, you could always print this page in Russian, the next page in Hebrew, and then staple them together. You know, that's how you'd make multi-language reports and things. But by the end of the 80s, we got all these different code pages. People are starting to get online. We're connecting, we're sending email. The web doesn't exist yet, but we've got FTP and Gopher and bulletin board systems. And it is pretty obvious we are going to need a better system to make all of this stuff work. Enter the Unicode Consortium, the Unified Coding System, Unicode. Now, Unicode started in 1988. This consortium was established as a sort of legal body in 1991. And I think their mission statement is brilliant. Their mission is to provide a single, consistent way to represent each letter and symbol needed for all human languages across all computers and devices. I'm going to break that down a second. All human languages. So everything that human beings use to read and write, they want to include it. And they want to do this on every system. All computers, all the devices. That is a hell of a mission statement, And the astonishing thing is that they pretty much did it. Now, they weren't just covering the human languages that we use today. They also wanted to include things like Egyptian hieroglyphs and ancient Sumerian, so that people doing archaeology and translating historical texts didn't have to come up with another system. And they realized early on that the only way to get all computers and devices is whatever you're doing, you need to make it really good, you need to make it really elegant, and you need to make it free. You need to provide a compelling solution so that other people will embrace your technology instead of trying to invent their own version because they think they can do a better job. Let's have a look at these. These are two sets of letters. Do you think these are, look at them for a second, do you think they're the same letters? Do you think this is the same string and the same alphabet? I'm going to give you a little bit of context to work with. Do you now think that those are the same? Well, they're not, they're the same shape, but they're different letters. The top one, that's a horosho, which is Russian, and the bottom one is exoplanet. It's not even the same sound. Hor and ops, XOP. These are different alphabets. The same shape is standing for a different sound with a different meaning in a different context. The fact is the same shape is kind of a coincidence. What about these? Now, these have the same sound. They are both T, and actually, they are the start of the same word. The top one is tigre, the bottom one is tiger. Same word, same root, it means the same thing. Are they the same letter? Does the Russian word for tiger start with the same T as the English word for tiger? There is no real answer to this. One of the things the Unicode Consortium had to do is to decide, is that the same letter or not? Can you write Russian using an English T? They decided you can't. They decided that even if it's the same shape and the same sound, if it's part of a different alphabet, then it gets a duplicated encoding. So they made this decision that T, that's a Russian T or Cyrillic T. The T on the bottom, that's a Latin T. Different alphabets, they get handled differently. Now, take a look at this word here. Now, I'm British. Like I said, I grew up speaking and reading British English. Good morning, this is the BBC, that kind of thing. So when I travel, I go to places like Norway and Sweden and Portugal, and I see words like this, and my English British brain goes, oh, I can read that, apart from I don't know what those are, so I'll just ignore them. And I'll go to the hotel desk and go, excuse me, can I have a half owner, please? And they will roar about laughing, because that is not how you pronounce. I think a hofena is close, but I'm sure somebody in the chat speaks better Norwegian than I do. But these are different letters. You know, in English, we just ignore, English speakers tend to just ignore the accents because it turns it into something we can recognize. So we'll say half owner. And, you know, when I'm just trying to get a hairdryer in a Norwegian hotel, hey, no big deal. You know, what's the worst that can happen? But there can be much more significant consequences to this. Let's meet some friends of mine. Let's meet Francois Boris, who is an archaeologist, and we're going to meet Motley Crue, the rock band. And then we are going to write in our English document that Francois, the archaeologist, went to the Motley Crue concert. Now, this is English. But there are characters in this piece of text which do not appear in the English alphabet. We have a C here with a sedir underneath. We have the AE in archaeologist, which is an archaic way of combining certain kinds of characters. And we have the O and the U in Motley Crue, which have the heavy metal umlaut, which is a thing that bands use to look cool. Now, the first time Motley Crue went on tour in Germany, they could not work out why the audience was chanting Mötley Crüe, because it never occurred to them that the thing they did to look cool was a different letter in a different alphabet if you go to other countries that are not the United States. So, you know, we have these conventions, even in English. We pull in letters and punctuation and things that do not exist in English. We need a consistent way of encoding characters like these. Now, introduce you to another friend of mine. This is Magnus. Now, you might think this is Magnus Mårtensson. This is Magnus Mortensen. Magnus is Swedish. And a few years ago, Magnus is flying to the US to go to a conference in America. And he got into a little bit of trouble at the border. You see, that O sound there in Mortensen, that is a distinct letter of the Swedish and Norwegian and Danish alphabets. Now, Magnus is traveling on a Swedish passport, which says Mortensen, but then there's a little strip across the bottom. If you look at your own passport, the 2 rows across the bottom, they have to be in Ascii, they have to be machine readable. And the Swedish government says that R letter is transliterated as AA, 2 A's, when you turn it into Ascii. The people who printed Magnus' airline ticket were not the Swedish government. They just took the circle off, and he's Magnus Mårtensson now. And then he tries to get into the US with an airline ticket that does not exactly match the machine-readable name that is printed on his passport. And of course, the American border control agents, they are very famously forgiving and understanding. No, they're not. He had to do quite a lot of explaining. And, you know, Magnus is an affluent, well-dressed white guy going to speak at a technology conference. Imagine the number of people in the world for whom that could have been a really big deal. You know, they turn up at the border, and just because one computer and another computer are using a different system, they get, you know, locked up, imprisoned. All kinds of things happen because the paperwork doesn't match through something which is absolutely no fault of theirs. We're not even getting warmed up yet. Here is a list of cities in Europe. Now, we are going to take this list of cities and we are going to put it into a SQL Server database. We're going to declare an n-varchar, so a Unicode varchar column with up to 128 characters in it. And we are going to insert Berlin, Aachen, Zurich, Aarhus, and Örebro into that. And then we are going to select star from cities. And there we go. Put our data in, got our data out. We've encoded something, we've decoded it. Brilliant. It's all going wonderfully. Let's have a look at the city of Örebro. It's not there. Why is it not there? Let's try that again. Maybe it needs a capital letter. Try it again. Nope, it is still not there. This is interesting. Let's do a very quick sanity check on whether strings are the same as themselves. If these 2 strings are the same, print yes, otherwise print no. No, they are not. These strings are different. Why are they different? Well, if you are from Scandinavia, you're going, of course they're different. If you are from the United Kingdom, you're going, maybe those 2 dots matter, I don't know. Because we as as humankind, we can't really agree on what's the same and what's not, because different people have different conventions about how to do it. In SQL Server and most databases, they will not help you with this. They have defaults, and it is up to you to be specific about what matters. If we want these to be the same, we must say to SQL Server, please use the Latin general case insensitive, accent insensitive set of rules when you decide what order strings should go in and whether 2 strings are the same. And if we do that, it says yes. Now, collations, like I said, they aren't just about comparison. They're also about alphabetical order. We're going to select star from cities, order by name, and we are going to run that. And we get Aachen, Aarhus, Berlin, Örebro, Zurich. Makes sense to people in the UK and North America. Probably doesn't make sense to anyone watching from Scandinavia. Some of you are probably looking at that going, but that's not right. Let's do the same thing now. If we collate using the Finnish-Swedish case-insensitive, accent-insensitive collation, Örebro is now at the end after Zurich, because in the Finnish and Swedish alphabets, the O with the umlaut, the sound, that appears after Z. It is a separate letter of the alphabet. But if we do the same thing using Danish and Norwegian collation, Aachen and Aarhus are now at the end. Berlin is first, then Zurich, then Örebro, then Aachen, then Aarhus. And you might be looking at this going, but I don't understand why those would be at the end. And to understand how a SQL Server collation comes up with something which to us appears to definitely not be anything to do with alphabetical order, it's not that A's at the end. If we add Athens to this list, Athens is definitely first before Berlin. We need to learn some history and some culture. We need to understand that the city of Aarhus, the second largest city in Denmark after Copenhagen, was officially spelled Aarhus with a little circle above the O from 1948 until the 1st of January 2011. What? Well, it used to be Aarhus with 2 A's, AA. In 1948, there was a spelling reform in Denmark. They changed the alphabet to be more Swedish and less German. And they added 3 new letters to the Danish alphabet, the alphabet that's used in Denmark to print books and government releases and everything, basically. And they said, these are new letters, and all the places and people that used to be spelt with the 2 A's at the beginning, which is the R sound, those are now going to be spelt like this. And so Danish alphabetical order ended up as this, which kind of makes sense. The A for Aachen is at the beginning because it's A, B, C, D, E, F, G, Z, and then R appears at the end of that. But then in 2011, the citizens of Aarhus voted for reasons related to internet search engine optimization and tourism, that they were going to change the name of the city back to Aarhus. Same pronunciation, but it's now spelled AA. And so the convention that we've ended up at is any place names, places, people, companies, proper nouns, starting with AA, they go at the beginning of the alphabet unless they are Scandinavian. So the city of Aachen, which is in Germany, goes at the beginning of the Danish alphabet, and the city of Aarhus, which is in Denmark, goes at the end of the Danish alphabet. And programmers are looking at this going, how are we supposed to know that? How does SQL Server, how does Windows look at that piece of text and know which ones of these are in Scandinavia and which ones are not? And the answer is, you can't. It's impossible. There is not enough information in the text itself to put it in alphabetical order according to the rules of Scandinavian orthography. So if you need to get this right, what you got to do in your code is you need to add another column. And you add another column, which is like, I know what it looks like, but when it comes to alphabetical order, this is what you should use as the sorting key, even though it's not the same as the thing that is going to get displayed to the end user. So adding something like a sort name column will allow you to then sort this according to a particular alphabetic collation and get the results. Now, I'm not going to say the right answer, because as we've just seen, there's no such thing as a right answer. There's right answers, there's wrong answers, there's the answer that is correct for a certain person on a certain computer in a certain place with a certain set of expectations about what they are going to see. But if you've ever used Norwegian Windows and you wonder why aardvark appears at the end of your file name listings, this is why. Now, the other interesting thing, the reason why I like talking about these kinds of things is, people often say, you look at the world around you like, yeah, but I just program computers. I'm not really interested in politics. You cannot take politics out of technology. You cannot take history out of what we do every day, because so many of the decisions that have informed the languages and the standards and the systems, the stuff we need to know to do our jobs well, comes from history and politics and warfare and humans just being messy for tens of thousands of years. And if you don't understand this stuff, you're going to spend your life going, I just don't get it. There's so much stuff here I have to learn that doesn't make any sense. But when you understand the reasoning behind it, often you'll be like, actually, yeah, it kind of sucks, but I don't know what I'd have done differently. And it just kind of, it becomes easier to sort of make your own decisions about how to approach certain kinds of things. Let us go back to la cedilla, which is here underneath the letter C here. Now, you got to remember, Unicode did not set out to tell people how to read and write. Unicode set out to look at what human beings were doing and give them a way of translating that in and out of computer systems. And so, all these different languages, from, Egyptian hieroglyphics to American heavy metal bands, they came up with all these different solutions. And in some cases, that meant there's more than one way of doing the same thing. This character here is officially called the Latin capital letter C with cedilla. But Unicode has given us two different ways of writing it. It's given us this character. That is the character that appears in the French alphabet. But it's also given us, you can take C, which is Unicode 0.43, the same as it is in Ascii, and you can add this thing here, which is a Unicode combining character cedilla. And when you plug those two together, it'll draw the C as a tail, it'll draw the hook as a tail underneath the C, and you'll get the C with a cedilla, you get the accented character. Now, these combining characters, you can add more than one. You can combine lots of characters with other combining characters, and you can add more, and you can add more, and you can add more, and you can keep stacking them up until you end up with Zalgo text. If you've ever seen, the famous Tony the Pony Stack Overflow answer or any of the forum posts where people use Zalgo, that's what Zalgo is. It's regular text. The stuff in the middle is Ascii with combining characters just piled onto it until, if you're lucky, it just looks like a mess. If you're unlucky, this can actually crash the system that is trying to render the text, because it's just pushing all sorts of edge cases. It's a really good destruction test way. If you're writing algorithms that are expecting to render Unicode text, put some Zalgo text in it and see what it does. But what this means is, if we take Francois and we look at this as a stream of bytes, as a set of bytes, stream of characters, there are two different ways of representing it. And they look the same, and they are pronounced the same. But how do we know if they are the same? How do we deal with this fact we now have two different ways of representing the same thing? Well, this is where Unicode, again, they don't tell us what to do, they give us some options. Unicode gives you 4 different kinds of normalization. They are called, confusingly, they are composed and decomposed. And then there is a canonical composed form, and there is a canonical decomposed form. And so the K in this example, the K stands for canonical, because C is already used by composed. Composed basically means squish it together into the smallest possible number of characters. So if you can replace this plus this accent with one of those, throw those away, put in one of those instead. Decomposed means the opposite. Break it out. This accent, 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 break it out into the biggest number of characters you can. Now, let's have a look at an example of this. Let's have a look at, we've got a word here, buna, and then we've got the same buna, or bunya, but this time we're going to add the combining breve character as a separate character there. And I'm going to run that example. I'm going to do a .NET run on it. And this is going to say these two strings they're not the same binary equivalent. S1 is not equal to S2. S1 equals S2 false. But if we compare them using Unicode form C, Unicode form D, KC, KD, they are equal under all of those. Let's have a look at another example. There are characters in Unicode which are fancy looking letters, like these ones here, which are letters in circles. Are these two strings the same? Now, there is no right answer here. For some purposes, if we're looking for a piece of text in a file, they may be considered equivalent. If we are looking for an exact binary match, maybe they are not considered equivalent. If we run this example, what we get at the other end of this is they are false unless we apply the canonical composition rule. So we've now got a bunch of different ways of representing the same character. We got a bunch of different ways of comparing characters. We got a bunch of different ways of putting things in alphabetical order. And although, this is all really, really good progress, what we've uncovered is there's a bunch of different human conventions that computers can't get right unless we give them a hint, unless we tell them what set of rules we are expecting to apply to, hey, it's just plain text, right? It's like, no, it's not plain text. We need to know more about the context in which this text is considered to be plain. Now, the next interesting thing that we get onto here, we've got all of these wonderful ways of representing characters by gluing whole bunches of bytes together. And we now need to think about, well, we've got all these bytes. what do we do with them? How do we put them reliably into the system, and how do we get them out the other side again? Now, my introduction to the wonderful world of Unicode stream encoding started about 5 years ago when I got into work one morning and I got the, dude, I think we've been hacked. And, you know, I get this a lot because anyone who works in IT gets this a lot because someone's like, oh, the hackers have broken into my computer. It's like, no, they haven't. You've just right-click reveal codes or inspect or view source or whatever, or you've accidentally put your phone into Greek instead of English. Don't worry about it. It's not hackers. But on this particular occasion, the person saying, I think we've been hacked, was a very, very competent cybersecurity engineer, information security engineer. I was like, why do you think we've been hacked? And he said, there is Chinese in the Windows event logs. I was like, don't be ridiculous. No, that's not a thing. And we had a look. And sure enough, there was Chinese in the Windows event logs. Now, this is when I was at Spotlight. Spotlight's a British company based in London, some customers in Western Europe. We have no Chinese engineers. We have no Chinese language systems. We do no business in China. We have there's no Chinese, basically. There are no Chinese characters in anything that we do. And so it's like, right, we may have a problem here. And, you know, the nice thing about working with a good team is, you know, one person, right, you check the firewall logs, see if there's anything suspicious, look for, you know, Chinese related IP addresses, just in case. You go and look through all the database tables, see if you can find these characters anywhere. Is this data that's been injected into our system? Where did it come from? Somebody else is, you know, telling everyone, hey, we're just looking into this incident, which kind of leaves me with nothing to do until someone comes back. So I sit down and I start ranting about it on Twitter. And I say, the incoming tabular data stream, Chinese, it's going to be one of those days. And within about a minute, I get 2 replies back. One is somebody saying, that looks like a Unicode mapping error. And the other one is the low bits are null. So this is UTF-16LE being mistaken for UTF-16BE or vice versa. And I'm like, all right, I should probably figure out what UTF-16LE and BE are really, really fast in case this is important. So I start Googling stuff and looking things up and reading documentation. And that was the day I learned about the wonderful world of Unicode character encoding. Now, have a look here at the word delete, which shows up sometimes in databasey things, right? Now, internally, Windows and Java and JavaScript, they use a thing called UTF-16. Every single character is stored in Windows as a pair of bytes. The reason they do this is it makes certain things fast. You always know if there's, you know, 160 bytes in a thing, you can know how many characters are on that. You can advance by certain numbers of characters. You can calculate record lengths because you know that every character is 16 bits, 2 bytes. Now, if you encode the word delete in UTF-16, what you get out is this. The D is a 00 and then the 44 because Ascii, 65, 6C, so on, so on, so on, so on, so on. Now, if you flip those backwards and then read it out, you get Chinese. You get Chinese characters. We did punch these into Google Translate. The left-hand one there means placing a pearl in the mouth of a corpse, and the next one means preparing a chicken for slaughter or some such thing. See it, David. Take it easy. So this was kind of promising. It's like, okay, we can turn perfectly good SQL into Chinese by getting the bits in the wrong order. Moves the question, why are the bits in the wrong order? Well, it wasn't like one of the Windowses had flipped from being big N to little endian, because, you know, Windows does not do that. We determined after quite a lot of investigation what had happened. There was a faulty network switch in the virtual network that was running the database system, and it was occasionally dropping a byte. And when it dropped a byte, what it meant is that everything else was getting shifted sideways without any indication that there was now an off by 1 error in the byte stream. And that is where we were getting the weird Chinese characters coming in from. So we've rebuilt, whatever. I think we actually just phoned someone up and shouted at them until they did it for us. But the network switch was fixed. The problem went away. And we all then sat down and went, well, that was kind of weird. What are we going to do tomorrow? Now, This UTF-16 system, internally, like I said, Windows, Java, JavaScript, they use UTF-16 because there are compelling advantages when you are dealing with something like an operating system. For OS type stuff, performance is really, really important, and most of the stuff you're dealing with is relatively close by. You can assume that storage is cheap, and bandwidth, you are talking about, hard drive bandwidth and memory to CPU level 1, 2 cache bandwidth. Once you get out onto the network and the internet, the kind of parameters change a little bit. We don't want to run the entire web on UTF-16 because most of the web is made of ASCII. Even if your web pages are in Korean or Hebrew, all the HTML markup is ASCII. Your JavaScript is ASCII. Your CSS files are ASCII. Now, if we use UTF-16 to push ASCII across the web, we are pushing zeros. Every single character is followed by a pointless zero, which wastes a whole bunch of space, wastes bandwidth, files end up twice as big as they need to be. There are all kinds of reasons why we don't want to do this. UTF, the Unicode Consortium, came up with an encoding system for handling this that I just think is beautiful. It's a thing called UTF-8. Now, what they said is, first of all, any byte starts with a 0, that is 7-bit ASCII, same as it was in 1965. We haven't changed that. All the old ASCII will be readable forever. We are kind of just transplanting that beautifully into our new system. If you see a byte that starts with a 1, that is part of a multi-byte sequence. That character needs more than 1 byte. You know how many bytes? Well, it varies. UTF-8 is a variable length encoding system. If it starts with a 110, it means that 2 ones means this is a 2-byte character, and then a 10 means this is a continuation character. If you're searching through a file and you see a byte starting 10, it means you're in the middle of a letter right now. You need to back up, find the beginning, find the 11, and then if it's a 110, you read 12 bytes. If it's 1110, you have to read 123 bytes. 11110 means you need to read 4 bytes. Now, it does actually, in theory, go up to 8. The reason they cap it at 4 is that if you had UTF-8 all the way up to an 8-byte encoding, you can't translate that to anything else. There is a UTF-32, which is round-trippable from UTF-8 to 32 and back again. So that's why they kind of kept it there. Now, this is such a brilliant encoding. ASCII files are still ASCII. Files that just use ASCII are the same format, the same length. Everything about them is the same as it ever was. If you're using, Western European alphabets, Cyrillic alphabets, those kinds of things, those are 2 bytes. They encode relatively easily, but it gives us a huge amount of headroom. It gives us space to encode all the alphabets we know about, a whole bunch of stuff that we haven't thought of yet, distant alien civilizations we haven't made contact with. That's okay. We'll have space to put them in Unicode when we make contact using UTF-8. Now, Unicode covers all human languages, right? All the ones we used to use, like ancient Sumerian, all the ones we use today, and all the ones that we're still inventing. And some of you are probably thinking, but we don't really invent languages and alphabets anymore. We kind of got enough of those. But that's not true. There is a new language with a new alphabet that was invented within my lifetime that I would wager good money all of you has used in the last 24 hours. It is the language called Emoji. Emoji didn't exist until 1991. There was Shigetaka Kurita was the artist who invented them, working for the Japanese mobile phone company Docomo. They were building a thing called iMode, which was a really early mobile information system. And they wanted a way to use images to do things like weather reports and bus timetables and those kinds of stuff. And so Kurita came up with this, the set of 176 emoji that is now on display at the Museum of Modern Art in New York. And these took off in Japan like wildfire. Within about 6 months, nobody would buy phones that didn't have emoji support. And it was originally just restricted to Japan. It was a Japanese domestic mobile phone market thing, right up until the point when in 2008, Apple introduced iPhone in Japan. And to sell a phone in Japan, it had to support emoji, which meant they included emoji support in iOS, and the iPhone keyboard supported it. And you could switch it on. And people around the world worked out that if they enabled the Japanese keyboard, they could send emoji. And suddenly everyone else is like, wow, these are amazing. You can send text messages with smiley faces in them. And then they start asking questions like, why are there emoji for sushi but not for tacos? And why are the doctors and the chefs and the police all white guys or like Simpsons yellow guys? But they're all kind of stylized caricatures of male characters, The emoji set included national flags when it rolled out on iPhone. But people are like, well, why is the flag of Palestine not in here? Who's making these decisions? Now, in 2015, Unicode took a massive step towards inclusivity by they introduced the ability to change the skin tone on emoji. And the way they did it, I think, is actually really clever. You know, we talked about the combining characters. What they did is they introduced combining characters for skin tones. So you can, in theory, take any emoji which portrays, you know, a human body, and you can say, oh yeah, and please make their skin the color represented by this tone. And so you get different thumbs ups, you get different smiley faces, different grimaces, all these things suddenly. And if the device you're on doesn't know how to combine those two characters, it'll just render them side by side, which means even if you don't get the exact likeness, the meaning is still clear. You can still see what they were trying to communicate there. Now, they add new emoji to the collection every year. And as you can kind of see, this is the last set that was added in 2020. And there's a whole bunch of combinations of, you know, gender presentation and family units and all these kinds of things here. And they have not been through and added individual emoji for every single combination that anyone can think of. What they've done is they've used the power of Unicode to allow us to add all of these. Let's say that we want to send an emoji of female astronaut. There is a thing in Unicode called a zwidge, zero width joiner. We are going to send a woman followed by a zero width joiner, followed by the rocket ship. And that zwidge in the middle says, if you can, combine these together and give us whatever your platform thinks is a combination of a woman and a rocket. And the convention says that is a picture of an astronaut who presents as female. And we can combine them even further. You want to send someone an emoji of Mae Jemison, who flew on the space shuttle, woman plus skin tone plus the zero width joiner plus the rocket emoji. So by combining these, you know, people and modifiers and objects and professions in all kinds of ways, it's basically down to the handset manufacturers now. It's like, how many of these do you want to get your artists to create a glyph for it and include it in the system that we are going to be rolling out? Now, I want to talk about flags for a second, because flags are interesting. Most of the flags that exist in Unicode, if you were to type this, which is it's the flag of Belarus, there is a set of characters, set of alphabetic letters in Unicode, which were designed for tagging. And they were rolled out in the 90s in case we needed them. And then in 2005, they were deprecated because we couldn't think of anything to do with them. And then they were very rapidly undeprecated again, because it turned out people had been using them as a way of drawing flags. So if you take the regional indicator symbol BY, that is the country code for Belarus. You combine those two together. If your device supports it, you'll get the Belarusian flag. If your device doesn't support it, you'll get BY, which is the ISO country code for Belarus. Now, this works for countries that have an ISO code. England is not a country according to the International Standards Organization, because England is part of the United Kingdom, which does have an ISO code. The flag of England is created using the black flag, then these alphabetic tag characters here. These are the ones that were taken out and then put back in to add GB for Great Britain, ENG, the code for England. This is used for England, Scotland, Wales, and Texas are the only flag, the only regional flags in the emoji set. Incidentally, on Twitter, emoji are stored specially. You know, the 280 character limit? Well, it's not actually a 280 character limit based on bytes. If you send someone a tweet full of England flags, you can send 140 England flags, which is actually 140 times 5 is 700 bytes in a single tweet. So that's the biggest tweet it's possible to send. So that might be useful. And the pride flag is the white flag, a zero width joiner, and a rainbow. Now, these are three different ways that we've come up with of including different kinds of flags in emoji representation. Does anyone recognize this? Anyone know what country this is the flag of? Because this is the flag of the Republic of China, which is known to most people as Taiwan. And this flag is controversial. If you go to the People's Republic of China, which is the big mainland country that most of us know as China, this flag can get you in a lot of trouble. If you fly it, you can be questioned, and it's generally seen as supporting Taiwanese independence, which is something the Chinese government, the People's Republic of Chinese government, is very much not in favor of. Now, if you go into an iPhone and you type Taiwan and you put the flag in from your emoji keyboard and it's there, and then you go into your regional settings and you change your phone's region to China mainland, and you go back and you have another look at your Taiwan emoji there, you'll see, one, it doesn't render anymore, and two, it's disappeared from the keyboard. You can no longer type it. This is Apple's solution to China going, you are not selling hardware in our country which supports Taiwanese independence. And Apple going, all right, we'll just say, so if you're in China, you can't do it. Is that enough? And presumably the Chinese went, yeah, that's fine. Microsoft Windows, and I think most Microsoft products, when we are not going near that with a 100-foot stick. If you go onto my Twitter profile, there is this little flag at the end of my name, which is the flag of the European Union. Now, if you look at it in the Twitter web interface, that's a PNG being rendered by Twitter's own code. That's not my operating system drawing that flag. If you look at the text that appears there, you just get E and U, because Windows does not include any regional flag emoji. Doesn't do it at all. If you ask the operating system to draw a flag, you just get the two regional indicator symbols, EU for any country. The only flags that Windows supports natively are the pride flag and the pirate flag. So no countries allowed, but Windows is completely at an operating system level in favor of gay pirates, which I think is actually pretty cool. Now, one more thing, the home stretch, the last mile. We've talked about all these different languages and alphabets and symbols and encodings and things. There's one more little thing that I want to tell you about, which is just another way of doing interesting things with text. If you look at the logo for my company and you look very closely, you'll see that the letter T and the letter I there are kind of joined together. Now that is text. That is ordinary text set in a typeface called Lato. It's not a picture, it's not an image, it's not an SVG or anything. This is something called a ligature. And a ligature is something that is baked into the font that says, if you see this letter followed by that letter, hey, I've got a special way for you to draw that combination. Typographers and typesetters used to use ligatures a lot when they were setting books using, movable type and, hot metal type print. They'd have a little tray of ligatures. They'd be like, oh, TI, yeah, we'll use one of those. That'll make it look nice. So you'll see this a lot in old printed material. And now that more and more people are using screen readers and stuff, a lot of these conventions are starting to come back, and we're seeing them happen digitally. Now, the fantastic thing about ligatures is there is a typeface that you can download and you can install and you can use in things like VS Code, which makes your code look like this. Now, this is FizzBuzz in F#. And if you write F#, which I'm sure some of you do, because F# is a very, very cool language, you'd be like, F# doesn't have weird triangles and arrows and stuff in it. F# just uses Ascii. And this is what F# normally looks like. But my F# looks like this. It's the same file. It's the same code. It's exactly the same set of ASCII symbols. They are binary identical, but I am using this typeface, which is a font called Fira Code. And Fira Code basically looks for common programming character sequences, like a double equals or a triple equals, and replaces them with something that is a little bit more readable, and also it looks cool. It improves readability. It replaces various sequences with these extra glyphs, and I love it. I think it looks really nice. I've been using it as my main programming font for years. There are some other programming fonts out there that do this, but go and check out Fira Code if you want your programming to look like this kind of stuff here. It genuinely does improve readability, and after a while, you'll find certain things that are easier to pick out, particularly the difference between double equals and triple equals when I'm doing JavaScript. I find this makes it much easier to see what's what. Now, I want to wrap up today by sharing a little travel story with you. We saw the flag of Belarus there in an example a minute ago. And Belarus, I love traveling. I love going to Eastern Europe and Russia and Ukraine and Belarus and all these kind of places. And the first time I was in Belarus a few years ago, I was walking around the streets and I couldn't read. I could not read the Cyrillic alphabet. I started learning since then, but I couldn't read anything. I had no idea. So I'm wandering around. I'm like, this is weird. I can't read the road signs. I can't read the shops. I can't read the restaurant menus. But I can read all of the license plates on all of the cars. Now, I did a bit of digging, because when I see things like this, I go and I dig. I think this is interesting. And I found out something, really interesting. There's a thing called the Vienna Convention on Road Traffic, which dates back to 1968. 60s is kind of when we agreed all this stuff. And since then, we've just been trying to catch up. And 36 countries, including what was then the Soviet Union, signed up to this treaty. And one of the terms of that treaty was, if you're going to drive your car internationally, you are only allowed to use characters from the Latin alphabet on your license license plates. Now, in the 1960s, Soviet Union license plates used the Cyrillic alphabet, all of it. And I said to a couple of friends of mine in Belarus and Russia, I was like, what's the deal with the Vienna Convention? And they're like, nobody drove their car out of the Soviet Union in the 1960s. You couldn't. And even if you could get a travel permit, you couldn't, because it was a long way. And if you could get a permit, and if your car made it to the border, when you got to the border, they would give you different license plates, and they would be signed out. And that meant that they could track who left the country with what vehicle and where they took it. And you had to bring the car back and swap your license plates back when you re-entered the Soviet Union. Now, when the Soviet Union collapsed in the 90s, all of the countries, the former Soviet states like Ukraine and Belarus, they all reformed their vehicle registration systems. And they came up with license plates like this. Now, you can read, even if you can't read the Cyrillic alphabet, you can read all of the characters on these license plates, right? And this is what I thought was really, really cool, is the solution they came up with is they looked at the two alphabets. They looked at the Latin alphabet. The law says you can use these on license plates, and the Cyrillic alphabet, which is the one that they all read and write and work with every day. And they realized that there is an overlap in the middle. There is a set of letters that appear the same shapes. They're not the same letters, but they're the same glyphs, the same letter forms appear in both of those alphabets. And so Ukraine and Belarus, Russia doesn't have the I character, doesn't have the vertical I, but Ukraine and Belarus are like, this is the set of characters we are going to use on our license plates. And if you rearrange those letters, they spell the words pike matchbox. So this is what I want you to take away from the talk today. The next time someone says to you, hey, I'm going to send you a plain text file, just look at them and go, do you know pike matchbox? And if they say pike matchbox, then they've seen this talk, and they know about Unicode, and they know about big endian and little endian and Ascii and character tables and compositional encodings. They know all this other kind of stuff. And you can be confident that when they say plain text, they mean, I understand the cultural and technical requirements associated with your situation. I will send you a file that you can read. And if they say, what's pike matchbox? It means you have no idea what you are going to get. Thank you very much.
Thank you, man. Fucking.
I'm just going to plug something for 1 minute before we throw it open to questions and chat and stuff. This is the marketing bit of the talk. So one of the reasons I do that, actually, one of the reasons I do this is I enjoy it, and it's fun putting stuff together and talking to you all. But I also do it because I sell workshops to people, and I teach .NET and JavaScript programming and all kinds of stuff. And go out and check out. You go to ursatile.com, which is my corporate sensible website that I use to people to persuade their bosses that I know what I'm doing, which I do. You'll find a list on there of all the workshops I'm running. We got a couple of dates coming up. I'm doing some distributed systems workshops over the next couple of months. I got some JavaScript web programming, and there's new dates for those going up all the time. So check that out. Share it with your team. Share it with your boss. Tell everyone, send it over there. And it would be awesome to see you on some of those. And that's it. End of marketing. Thank you.
Great. Yeah, okay. We've had a few questions from the box. Robert Katz asks, how about Unicode signatures as a
Luke, your mic has gone extremely quiet.
How about now?
Better? Yeah, brilliant.
Nice. Yeah, Robert asks, how about Unicode signature as a first characters in a text file? How does that work?
So are you talking there about a Unicode byte order mark, Robert? Because Unicode, if you have UTF-16 text files, they can be big endian or they can be little endian. And the byte order mark is the first character in a file, and that's the thing that the operating system looks at to work out which way round it's supposed to read the bytes in this file stream. And if it's missing, then sometimes you can open a file and be like, this looks like gibberish, and then you flip the byte order mark and you're like, nope, it's fine, it makes sense. Most editors now, the only time you'll see that is if the byte order mark in the file is actually wrong, because if it's there, it's normally correct. And if it's missing, most systems can take a pretty good guess just by looking at, well, which way around does this result in the kind of characters that normally happen on my operating system? Yeah, if you're talking about byte order marks, if you're talking about different kind of Unicode signature, I don't know what that is, but I can go and look it up. Lydia, hey, no, I don't do any stuff on Azure at the moment. I'm doing some, I have a distributed systems design workshop that I'm doing some stuff with Azure Service Bus and working that into it. But the stuff I mainly teach is REST API design and the gRPC gRPC, RabbitMQ, PubSub, SignalR, and a whole bunch of stuff about web programming and JavaScript, web components, and that kind of stuff. So,
and to do a shameless plug of our events, we did an event with Barry Lubrecht a few months ago, at the beginning of the year, in fact. So if you go on our YouTube account, yeah, we've had some stuff on Azure already. Also, Peter Detender did one on Azure DevOps. So there's a few things in the pipeline. Also, shameless plug, the next event with Dennis Frogop in 2 weeks' time. That's going to be centered around Azure IoT. So yeah, if you want to know anything more about Azure, yeah, there's a lot of stuff already.
Azure IoT is very, very cool, actually. That's definitely worth checking out.
I'll see you there then, Dylan. Yeah, sweet.
Cool.
Well, yeah, thanks everyone for coming. Number 11, we've got two more booked up, and about 3 or 4 yet to announce. So yeah, of course, you're here because you've signed up, but keep an eye on the page, and there's a few more to come in the next few weeks. So thanks everyone, and thank you, Dylan. Amazing as always. Need to get you on again in the future, man, because this was a good one.
I got so many talks. I've had a whole bunch of events in the last year, like, you know, we'll pay you to write us a new talk. And everyone has been like, well,
you told me that, yeah.
That's what I do for corporate gigs, is they're like, can you do something new? So at the moment I have like 10 talks that I've done once each. And at some point, because normally that also comes with like an embargo. I'm like, well, I'll do it at your event, and then you got like 6 weeks to put it out on YouTube and Twitter and everything before I'll do it anywhere else. So at some point, this huge library of new stuff I've written is suddenly going to be available for sharing and stuff. And yes, Manu, I hope to be live on a stage in 2021 somewhere, sometime. I cannot wait. Real stage. Cool. This is the online event stuff is you get the hang of it after a while, but it is no substitute. We do this for real. This is the point where we're like, right, let's all go around the corner and have a beer, and probably then another beer. And talk about stuff.
Everyone can buy you a drink afterwards.
Well, yeah, you know, I'm going to buy my own beer in lockdown. It's undignified.
All right. Cheers, everyone. Thanks for coming. We'll see you at the next one. Thanks, Dylan.
That's awesome. Luke, thanks everyone for coming. Thank you very much for having me. I'll see you on the internet. Take it easy.
Guys. Bye-bye.